I'm sorry if you can hear the drips of tears falling on the microphone as we have reached our very last lesson of college algebra. And as short and sweet as it is, it looks like I'm teaching you geometry. But never fear, there's some matrix action involved. I actually didn't know this one until I happened to be looking through the book on this day that I decided to record, and I decided that this looked like more fun than doing the advanced partial fraction problems, so hey, here we are trying this. Turns out that you can calculate the area of a triangle if you know its coordinates, the coordinates of its vertices, using a determinant. And let me remind you what a determinant is. We did determinants the other day when we were doing our matrix equations. When I gave you a matrix, we kind of need something right here. When I gave you a matrix the other day, when you were finding the fraction, when you were doing the 1 over and you were doing the little cross multiply, that was calculating the determinant. So technically, the determinant of matrix A is nothing more than when you do the little cross multiply thing, the AD minus BC, or 4 minus negative 6. Okay, in our case, though, it turns out to find the area of a triangle, instead of doing a 2 by 2 determinant, and you may recall that back in Algebra 2 with Cramer's rule, determinants were written between two vertical lines. For us to do it, since we have 3 coordinates to do the vertices of a triangle, it actually takes a 3 by 3 determinant. Now, there's absolutely no proof of this formula. I don't know where it comes from, but it was pretty cool, and I thought, actually, this could be kind of handy in life. So here is the formula for finding area of a triangle if you know the coordinates of the 3 vertices. You have to have coordinates. It is found by doing 1/2 times the absolute value, and this is going to get confusing, the absolute value of the determinant. Going to need a little more space here, of these coordinates we're going to put in here. Okay, now I know that's confusing. The reason the absolute value is on it, sometimes the determinant comes out negative. That has no impact. What you do is you put in the x and y coordinates of each of the 3 vertices, and then you do the third column with 1s in it. I found this really interesting because I have no idea how or why this works, but it's pretty cool. I checked it out. So it looks kind of confusing at first. Whoa, dude, it undid too much, didn't it? So you have to see it done. Once you see the numbers filled in, it's pretty short, sweet, and simple. So we have here a farmer plants a triangular field with corn. Now, I chose to do a word problem to make it a little more exciting. The first vertex is 1 mile east and 1 mile north of his house. The second is 3 miles east and 1 mile south. And the third is 1 mile west and 2 miles south. So it wants to know what's the area of this triangular field. Okay, well, that's a little bit confusing, and we need to turn it into coordinates because we need to be able to put coordinates in our formula. So let's plot these and turn them into coordinates. Assuming that his house is origin, then we need to go 1 mile east and 1 mile north. Well, 1 mile east and 1 mile north would logically then be a coordinate of 1, 1. The second vertex is 3 miles east and 1 mile south. So therefore, it would be logical to write that as the coordinate 3, negative 1. And finally, the third vertex is 1 mile west and 2 miles south, which looks like it would be the same thing as going negative 1, negative 2. Now that we have coordinates, we can put it in our area formula, very sweet and simple. It says you take 1/2 And we have to figure out the determinant. So we're actually going to go do this determinant on the side here. The determinant is where we put in the coordinates. Okay, the coordinates are 1, 1, 3, -1, and -1, -2. You just put them in, and then you run ones down the third column. Now, there is an actually fairly easy way. We did learn how to work this determinant by hand, but we're not going that far. We're going to go straight to our calculators. We did learn how to do it by hand back in Algebra 2. But we're going to go straight to our calculators and punch that in. So the big question is, how do I get that in my calculator? Well, menu. It's awful lot like a matrix, so we're going to number 7. But in this case, I want to tell it to do number 3, the determinant. Whoops, that didn't go where I wanted. Let's try that again. I'll punch the numbers here, 7, 3. Now, so you have determinant on there, but then you have to tell it the matrix to put in the determinant. So it's still back to matrix 7, 1, 1, create a matrix. We're creating a 3 by 3. And we're going to fill in those determinant values that we just did. So those determinant values were 1, 1, 1. That was pretty boring on the first one. The second was 3, -1, 1. And the third was -1, -2, 1. If we hit enter, we get an answer of -10. This is why they have the absolute value in the formula. So since we know that determinant's value is -10, we simply go back to our area formula, which said it's 1/2 times the absolute value of that determinant, and that's why they put the absolute value on it. So 1/2 times 10 is going to be 5. Now, we need units because we're finding area. We were in miles, so this would be 5 square miles of area. And you found the area of that triangle. Pretty slick, really. Okay, a couple other examples here. Throw a little more geometry at you on your last day of college algebra. We have a parallelogram that has vertices measured in feet at these following coordinates. It wants to know the area. Well, I'm going to do a really rough plot of these coordinates. -3, -4 is roughly down here somewhere. 7, 2 is far to the right and up a little. 7, 6 is far to the right and up higher. And -3, 0 would be back over here again. So, yeah, if I play connect the dots, looks like a parallelogram. How am I going to use the area formula to find the parallelogram? Well, sure, somebody out there is going, well, a parallelogram is nothing more than 2 triangles. So we can divide this however you like. But if I found the area of one of those triangles and doubled it, I'll have the area of the parallelogram. So you really just need to pick 3 of the vertices. It doesn't matter which 3. They'll work. In this case, once again, remember area is found. Area of a triangle, let me do that first, is 1/2 times the absolute value of the determinant. Okay, well, what determinant are we going to be doing? Well, let's put those coordinates in there. We're going to do -3, 4, 7, 2, and 7, 6. Put the ones down the third column. Now, I've already punched that one in here. Let me change pages. There are coordinates, and you can see that we get an answer of 40. So the determinant value is 40. When I pop back over, then I know 40, that was positive, so I don't need to do the absolute value of it. I'll get 20. Now, is that my answer? And now that's the area of the triangle. So the area of the parallelogram is going to be double that. So we really didn't need to multiply by half. It's going to be 2 times 20, or 40. They told us we were in feet, so it's 40 square feet. And then, last but not least, you can even do volume of a pyramid. They're telling you volume of a pyramid, I'll translate for you, is 1/3 times the area of the base times the height. Okay, we are in our case doing a triangular base. And so they want us to find the volume of this triangular pyramid whose height is 12 meters and its base has these given coordinates. So I know I'm going to do 1/3. I know I got a height of 12 meters. I just need to find the area of the base. Well, to find the area of the base, it's simply going to be the 1/2 times the absolute value of my determinant. What determinant are we doing? Pop those coordinates in there. Put some 1s down the edge and go to your handy dandy calculator. Whoops, that's not what I wanted. Sorry, just wanted to go a page over. And here we go. There are our coordinates. I got a determinant value of -26. I'm going to go back, pop that in my absolute value, so it's really +26, and half of that would be 13. So the area of the base is 13. And then when I multiply all three of these together, I know I'm actually going to be calculating 1/3 of 12 is 4, so all I really have to do is 4 times 13, and that would be 52. The question is what kind of units? We were in meters. Is it meters squared? No, this was volume, so this is meters cubed, and we just found the area of that rectangular triangle fairly easily as well. So, something to think about if you're a builder, have to do things with triangles. That's a really fast and easy way to get area. Hope you enjoyed it. It's been real. It's been fun. Of course, we're not done yet with college algebra because the ultimate, the fun, the excitement of the semester test is coming still. So look forward to that final. Happy finishing up with your partial fractions and your area.